Hi and welcome to this video on circle geometry, maths made easy. Now in circle geometry there's 9 rules that we have to remember. Now we'll go through them one by one, but they can be in any order. The first rule we're going to go through is if we have a circle and a diameter. Now remember, the diameter goes through the center of the circle, so we call the center O. Then if we draw 2 lines to form a triangle from each end of the diameter, where they meet the circumference of the circle, they will do so at a right angle. So that will be a right angle. And similarly, if we draw another triangle, that will be a right angle. Similarly, if we draw from the diameter to any point on the lower semicircle, the triangle formed, the 2 lines will meet the circumference at a right angle. So angle in a semicircle from the diameter meets the circle at a right angle. Now the second rule, sometimes we can be given 2 lines from the center of the circle O that meet the circumference of the circle. Now although we're not told these are the radii, so they're equal in length, so that's the radius of the circle, that's the radius of the circle, and also that's the radius of the circle. If we draw 2 triangles, then these will be isosceles triangles. And this angle will equal this angle, and this angle will equal. So those 2 angles will be the same, and those 2 angles will be the same, and these 3 lines are the radii. Number 3, if we have a tangent, so this is the tangent to the circle, and the tangent where it meets the circle and the radii where it meets the tangent, they do so at exactly 90 degrees. So this is the radius, this is the center of the circle, this is the radius, and where it meets the tangent it does so at 90 degrees. 2. If we have 2 tangents from the same point where they meet the circle at this point and this point, we draw from the center of the circle 2 radii, same length, they meet the tangents at 90 degrees, and if we draw from the center of the circle to the point where the tangent starts, we form 2 triangles which are congruent right angle triangles. So these 2 triangles will be congruent. If within circle we have a chord, so this is the chord, and the bisector of the chord is a diameter, so for it to be a diameter it has to go through the center of the circle. So we have a chord, the bisector is a diameter, then the bisector will cut the chord exactly in half. So this length will be the same as this length, and it will go through the chord at exactly 90 degrees. If we have a chord shown here to here, and we draw a triangle to the center of the circle and another triangle anywhere to touch the circumference of the circle, then if we call this angle A, the angle formed at the center of the circle will always be 2A. So the angle drawn from two ends of the chord, and the angle at the center is twice the angle at the edge of the circle or the circumference of the circle. Again, if we have a chord drawn here from this point to this point, this is our chord. I'm just highlighting it so we can distinguish it from the other lines. So that's our chord, and we have two segments. We have cut the circle into two segments, and we draw from each side of the chord a triangle which touches the circumference. Then the two angles in the same segment will be equal. So angles in same segment equal. Similarly, if we draw in this bottom segment, so this semicircle here, this angle and this angle will be equal. Also, this top angle, angle A, and angle B at the bottom, A plus B equals 180 degrees. If we draw a quadrilateral within a circle, then the angles, the four angles A, B, C, D, A plus B plus C plus D, the angles A, B, C, D equals 360 degrees. This last one is quite tricky to understand, and let's go through it. So we have a tangent which touches the outside of the circle, and here we have a segment of the circle, and this is our chord, which I'm going to highlight using this dotted line, but usually it's drawn as a solid line. Then this angle formed inside the segment and the chord, this angle B, so the angle between the tangent and the chord in that segment is equal to the angle formed in the opposite segment, so it's equal to this angle. So angle in opposite segment is equal to the angle from the chord to the tangent. As a quick exercise, let's find all the angles in this circle. Remember, this and this are parallel lines, so this chord and this chord are parallel. So we can find from our theory of parallel lines and transversals, E, D, C equals 180 115 degrees, which is 180 minus 65. Then we have several chords, and from this angle in the same segment we get ADB, the angle ADB is 28 degrees. Angle DEB is 65, so that equals angle DAB, that's 65. So remember, this ADB is the same as AEB, being the angle in the same segment, and this is the same as DAB is the same as DEB. Now we have the angles in opposite segments, so angles in opposite segments, so we have angle BCD is 180 minus 65, which is 115 degrees. Angle ABD, that will be 180 minus 65 plus 28, and that will be 87 degrees. And just see if you can find the rest of the angles using the fact that all the angles in a triangle add up to 180 degrees.